So in this short tutorial video, I'm going to be showing you as to how to calculate the EC50 value or the potency of an agonist in GraphPad Prism. So before we jump into the Prism file, let me introduce you to my raw data first. So here on the top I have stimulated my cells with a stimulant drug at a single concentration of -5 molar, or it is 10 raised to the power -5 molar basically. It's the log concentration, and I have three values arranged in a triplicate. So underneath that I have values for my agonist or inhibitor drug across a range of different concentrations starting from -15 molar or 10 raised to the power -15 molar all the way up to my highest concentration, which is -5 molar or 10 raised to the power -5 molar. And as you can see, against each concentration there is a data in triplicate. So again, my highest concentration, as I said, is 10 raised to the power -5 molar, and we also call it 10 micromolar. My lowest concentration is 10 raised to the power -15 molar, which is here, and you know that we also call it 1 femtomolar. So let's copy all this data and paste it into a Prism file, and let's see how our analysis looks like. So this is how your Prism file looks like when you open it for the first time. So we are basically interested to plot our values from the Excel sheet and draw a concentration response curve, which will be a sigmoid curve, and it will let us calculate the EC50 or the potency of our agonist. So as you can see in the left handle, we have a choice of different graph types. Now in order to draw a concentration response curve, you need to choose the XY plot from the given choices. Now just leave this X values bit for now. This is for our Y values. So since our data is in triplicate, so let's check this box. Let's check this circle rather. And since we have a triplicate, so it is okay. If for example we had a duplicate, so you will reduce this to 2. So let's make it 3 and then press create. There you go. So this is our X column, where we shall plot our X values or concentrations from the Excel sheet. Then for Y axis we have group A, group B, and so on. As we have only one agonist, so we shall put our values in group A only. If we had multiple agonists, for example, we could make use of the remaining columns. So let me copy my data for the X values or concentration values from the Excel sheet. So let's copy our X values from the Excel sheet. Select all these log concentrations. Copy and open the Prism file. Right click, paste data. Yeah, so our X values are arranged in the X column. And now let's go back to the Excel sheet. Copy all these concentrations, the values or the response. Copy, go back to Prism, right click, paste, paste data. Yes, so against each concentration you have data arranged in triplicate, and that will be plotted on the y-axis. So this will be our response on the y-axis, and these will be our concentrations on the x-axis. And as I mentioned, if we had more agonists, we can plot our data, put our data here, and get multiple curves. Now that I have plotted my y values for the agonist, let's go back into the Excel sheet and copy values of our stimulant compound, which is here. So select, copy, go back to Prism, and let me paste these values here. Yeah, so now I have put all my data here on the Prism sheet. So these are my X values, or the concentration values, the log concentrations. These are my responses from the agonist all the way down to here, and these three values are my stimulant drug, for the stimulant drug basically. So yeah, let's go further. Next we're gonna transform our y values into percent values, because we are interested in a percent response or percent inhibition of our compound. So let's convert or transform these values into percent values. For that, click Analyze. Here you can see it says transform and normalize, so go to normalize, hit OK. Here you can see it says subcolumns, average the subcolumns. Yeah, how is 0% defined? So smallest mean in each data set. Yes. How is 100% defined? So largest mean in each data set, and percent results as percentages. So we are okay. So let's press OK. So as you can see here, that our response values, or the agonist values, and the stimulant values are converted into percentage responses. Yeah, so you can see the highest inhibition has taken place at the highest concentration. These are the percentage responses of our stimulant drug, which are close to 100 or more than 100%. And then for the lowest concentration of the agonist, you can see here that it has very weak action at the lower doses as compared to the higher doses. So the next part of our Prism analysis is to draw a concentration response curve. So in order to obtain that, let's press Analyze, go to XY analysis, and yes, we need a nonlinear regression curve fit. So press OK. So then you have a range of different choices here. So dose response stimulation, dose response inhibition. So since our compound is an inhibitor, so let's select this, and then you are again seeing that we have different parameters to be selected according to the experiment that you have. So we have our log inhibitor doses here versus normalized response. So I choose this bit because I've normalized my y values, and this will be a variable slope. So let's click this. A dialog box opens here, so which says if x is not already the log of dose, go back and transform your data. So my x values are already in the form of log doses or log concentration, so I'm good to go. So yeah, press OK, and there you go. The Prism gives you these values straight away. It's a very smart software. So here you can see the best fit values. It's telling you the log EC50 or log EC50 value, which is minus 10.67. The next important thing is the EC50 value. That was our aim, or we call it EC50 value, which is 2.12 into 10 raised to the power minus 11. Yeah, it's kind of weird. I will explain it further. And if you come down to the goodness of fit here, so you have R squared values, which is 0.9906. So this value should be close to 1, and this represents that we have a good data fit. So let's come here, normalize of data, and you can see a beautiful sigmoid curve. So we have to play around with the x-axis here, and y-axis, because we see that there's a lot to be done here. We have a y value which is projecting downwards into the negative values. We start from 0. We want it to start from 0, and again the values on the x-axis are not properly arranged. So my highest concentration was minus 5, it is showing 0, and my lowest concentration was minus 15. So we'll do that later on. Let's change these x titles and y titles first. So I'll type in log, yeah, it comes up, log PN6047 molar concentration. So my agonist is basically PN6047, which is a novel analgesic compound, and I have researched this compound basically during my lab experiments. So for the y values, we can change it to the percent response. Yeah, so just click this. This is our percent response. So as you can notice that we have a very long y-axis which is projecting downwards. So in order to cut that axis, extra bit of axis, we have to double click the y-axis and uncheck this box. So this is my range. The minimum is minus 50 here, so let's change it to 0. This is our 0, and the max is 150, as you can see here. So instead I change it to 100. So my major tick interval is 50, which is okay. I don't want any minor ticks, so 0 ticks, no ticks. Hit OK. There you go. Our very nice y-axis starting at 0, showing 50% response and then 100% response. So as you can see, my x-axis needs sorting. So double click the x-axis. uncheck this box. So my minimum is minus 20. I want it minus 15.8, and the maximum should be minus 4.8. So mind you, this comes with experience, so if you play around with this software, one day you will be able to know how to set these ranges. So my major tick interval here is 5. I want my major ticks with a space of 2. So my starting x-axis is here minus 14, so it's basically starting at minus 15. Hit OK. There you go. So now that my y-axis and x-axis have been sorted out, here my highest concentration is minus 5 molar, all the way down to minus 15 molar as my lowest concentration, and there is a jump in concentration. There is no minus 6, there is no minus 8, there is no minus 10, there is no minus 12, there is no minus 14. So it looks all okay. Let's proceed further. So at this stage, if you click any of these error bars, for example, I click here, a dialog box opens and it says that plot is standard deviation or SD. I want my data in the SEM or standard error mean form, so I want to change all data sets and use SEM error bars instead of SD error bars. So hit OK, and it converts all my error bars into SEM form rather than the standard deviation form. So I personally don't like this normalize of data 1 bit, so let me delete this. So here I will show you one cool feature of Prism, that you can include your EC50 value and show the value up here right on your graph. So press anywhere here, right click, press insert info or analysis constant, and it shows the nonlinear fit of normalize of data 1, data set A. I click data set A, best fit values, double click, it says EC50 value, which is 2.12, double click, and yes, there you go. It shows up your EC50 value of the compound here. So let me pull it here. So now I want to introduce a text into this graph, so click this and type in EC50 space is equal to yeah, so looks good. And this 50 is basically my subscript. So yeah, I don't like it this way, so let me change it according to my style. So multiplied by 10 raised to the power minus 11, and this minus 11 is basically a superscript. So yeah, looks better. So my EC50 value is 2.125 into 10 raised to the power minus 11. So I hope this helps. If you have some comments, please write to me in the comment section below.